So for 6-5 day 2, we are going to add, subtract, and multiply radicals together. And then we're going to use conjugates to rationalize the denominator. Okay, we have talked about conjugates earlier this year, and we're going to talk about how to apply them so that we can simplify radical expressions. So radical expressions can only be added when the radicals are like terms. Okay, they are like terms when both the index and the radicand are the same. Okay, so they have to be the same. The index number and the radicand. Okay, and then sometimes they might not look like they are like terms and you have to simplify them first. So if there are any perfect squares or cubes, etc., do that first so that you can see if they are like terms. Okay, so we're going to do some examples of that together. Okay, so we're going to start with 3 root 2 plus 7 root 2. Okay, so when you are adding those together, it is very similar to adding when you have x's. If you had 3x plus 7x, what would that be? 10x. This is the same thing. You have the same index. What's the index for both of those? The index is 2, and then the radicand is the same. It's 2. So when that happens, all you have to do is add the numbers in front. 3 plus 7 is 10. And then your like term is the root 2. Okay, so that would be your final answer. All right, and then I want you guys to try this one. We have the cube root of x plus 2 cube root of x. Okay, so I want you to give that one a try. Okay, so do we have the same index value? Okay, so the index is 3, the radicand is x. Now when you're adding the numbers in front, the number in front here is 2. What's the number in front there? 1. Okay, so your final answer should be 3 cube root of x. Okay, so if you can't see a number there, remember it is 1. Just like if you were to do like x plus 2x, you would get 3x. Okay, you have that understood 1. Okay, and then the last one is the square root of 12 minus the square root of 3. So anytime you can simplify a radical, you are going to do that. Okay, you can always use a factor tree if you don't know what the perfect square is right away. But for a number like 12, we know 4 times 3 is 12. So that's going to be 2 root 3 minus root 3. Okay, the square root of 4 simplifies to 2. The 3 stays inside. And again, just like we did with this one, if you can't see a number in front, the number is 1. Okay, so 2 root 3 minus root 3 is just what? Root 3. 2 minus 1 is 1. The root 3 is going to stay the same. Okay, so anytime you can simplify the radical, make sure you do that. Now, you're not always going to have like terms that you can add together. Sometimes they're not going to be like terms, so you just have to assess each situation. So for example 3, when we're simplifying, we have 2 root 45 plus the square root of 48 minus 3 root 12. Okay, so when you're simplifying something like 45, that's something I would expect us to know is going to break down into root 9 times root 5, right? Because 9 is a perfect square that goes into that. So this is like 2 times 3 root 5. So when you simplify that, you have 6 root 5. Based on that, I want you guys to simplify the next two. The square root of 48 and negative 3 root 12. And then you're going to combine the like terms there, okay? All right, so for 48, again, it's okay if you don't know what the perfect square is. You can always use your factor tree, or some of you might know that the perfect square is 16, so you could do this either way. Okay, if it is a square root, remember, any group of 2 is going to come out. So if you have 2 groups of 2, it's the 4 that's going to come out. So this would be plus 4, and then root 3 would stay on the inside. Okay, that 3 has to stay in. 2 times 2 makes the 4. Okay, and then for 12, we know that's root 4 times root 3. So it's negative 3 times 2 root 3. So we should have negative 6 root 3. Now you can only combine your like terms, same radicand and same index. So 4 root 3 and negative 6 root 3, you can combine those. 4 minus 6 is negative 2 root 3. And then the 6 root 5 can't be combined. So this would be your final answer. Okay, generally whatever one is negative goes second. Okay, but you could also write it as negative 2 root 3 plus 6 root 5, and that would not be incorrect. All right, for B, you have the square root of 135 plus 5 times the square root of 10D minus 3 times root 60. Okay, now when you start to do a factor tree for a number like 135, okay, which is odd, so 2 doesn't go in there, generally what's the next value that you check? 3, right? Okay, so if you want to see if 3 goes into that value, all you have to do is add the digits up. Yep, so 1 plus 3 plus 5 is 9, and if 3 goes into 9, 3 goes into 135. Okay, so you can decide how you want to do your factor tree, because many of you also know that, oh, if it ends in a 5, 5 has to go in there. So you can either find 5 times the number, or you can do 3 times the number. Okay, so I'm going to give you a few moments to work on that. If you want to work on it with your row or your table, that is fine. So what did you guys divide by? Did you divide by 5? Okay, so it would be 5 times what? 27, and then once you get to something, if you know it's a perfect cube, you can just do the cube. Okay, if you divide it by 3, what did you get? What'd you get?
Oh,
no, sorry. Yeah, that's okay for this one. I'm like, no, I know it's 40 something. If you divide it by 3, what'd you get? 45. And then from there, 5 and 9, 3 and 3. So no matter which way you did it, you ended up with 3 3s and 1 5. Okay, and then once you do that, if it's a square root, a group of 2 comes out. So you'd have 3 root 15. Okay, and then if you were to split this up into 2 times 5, there's no group of 2. So this is going to stay as 5 square root of 10d. And then for 60, you have 2 and 30, 2 and 15, 3 and 5. So you have negative 3 times 2 root 15. So negative 6 root 15. And then once you get here, anything that's a like term, you can combine. Okay? So you have the root 15 and the root 15. So you're going to keep it as 5 square root of 10d minus 3 root 15. It is common for the negative 1 to go second so that you don't start with a negative. Okay, how'd that go? All right, let's try the last one. So sometimes you're going to have radicals that all have variables in them. So 10 square root of 175a minus 4 112a minus 2 square root of 63a. Okay, so when you're starting out, again, when you have these big numbers and we're doing them without a calculator, I want to see your factor trees. Okay, so the 175, you know that 5 is going to go in there. How many times does 5 go into 17? 3 times with 2 left over. So then the 2 joins the 5, 25. 5 goes into 25 5 times. Okay, you can also do that out. And then 35 breaks down into 5 and 7. Okay, so what we have is a group of 2 5s. So this becomes 5 square root of 7a. I write this out like this, especially the first time through, so you can see where the next step is going to come from. Once you've done this a few times, you guys are going to be able to jump to just saying that, oh yeah, this is 50 square root of 7a, that's fine. Okay, and then for one like 112, I'm always going to break it up if it's even with a 2. Okay, so if we cut that in half, you get 56, half of 56, 28, half of 28, 14, half of 14, 7. So if you have 2 groups of 2, we multiply them. Okay, and you still have that negative 4 on the outside. So it's negative 4, and then when you're looking at this part, 2 times 2 is going to be 4. So it's 4 root 7a. So this 4 is dropping down. This 4 came from simplifying the radical. Okay, so you have minus 16 root 7a. And then this one, for ones like 63, where there are multiplication facts that you know right away, just simplify it by thinking of this as root 9 times root 7. Okay, because then you have negative 2 times 3 root 7a. Okay, that a just drops down. So you have minus 6 square root of 7a. Okay, so all of these are like terms. They all have a square root of 7a, and then you can decide how you want to do the subtraction. Do you want to do 50 minus 16 and then subtract 6? You want to combine the two negatives and then subtract, that's fine. Okay, so what do you end up with as your coefficient? 28. Okay, so you could do this as negative 22. 50 minus 22 is the 28, which is the way I thought of it. You can also subtract that and then subtract. All right, so that is adding and subtracting radicals. Now we are going to multiply. Okay, so we have 12 root 10 minus 6 root 5 multiplied by 12 root 10 plus 6 root 5. Okay, so what we have here is a binomial times a binomial. Whenever you're multiplying two binomials, you employ the FOIL strategy. Okay, so we're going to do first times first. Okay, so we're going to do 12 root 10 times 12 root 10. Okay, when I'm doing that, I think of it as the 12 times 12, what's on the outside. Okay, so I have the 144, 12 times 12, and then what's root 10 times root 10? It would be 10, yeah? Okay, so then when you multiply those together, it would just be 1440. Okay, now I like to do FEAL. Remember, I like to do the inside for next. Negative 6 times 12 is negative 72. What's root 5 times root 10? Root 50. We're not going to worry about simplifying it yet. Okay, on the outside, I have 12 times 6, and then root 5 times root 10. So these are like terms, and they will combine to make 0. And if we study the original, we can see this is the difference of two squares here, right? You're going to have same number and then opposites. These are conjugates. Okay, so if you have negative 6 times positive 6, it would be negative 36. And then root 5 times root 5 is 5. So we're going to have to multiply those together. Okay, so I want you to do that multiplication however you want to without your calculator. I'm going to line it up. I'm going to do another strategy. And then you can do your last step as well. Okay, so I like to do the 30 times 5 and the 6 times 5, right? 30 times 5 is the 150 and the 30, so it's minus 180. So all I have to do is combine these two. So 1440 minus 180. 14 minus 8 is 6. 3 minus 1 is 2. Okay, so your final answer is going to be 1260. All right. And then for the next one, I want you guys to do your FOIL. Okay, and you do have a choice here because you have that square root of 12, and technically you could simplify it first and then you could FOIL. Okay, for this I want you to just FOIL it like it is because we're going to have a bunch of things to simplify in the next step. Okay, so go through your FOIL, write that out. We're going to simplify together. let's see how that went. So when you multiply, you should get 27 root 12 for the first. 7 times 4, 2 times 6. I did the inside next, so I got 12 root 18. And then the outside where I got 21 root 24. And then negative 9 root 36. And again, if those two are switched for you, that is not a problem. Okay, any question about the first step, doing the FOIL? How to multiply when you have radicals and whole numbers? Okay, because then from here, we're just going to be simplifying. So 12, because that's the square root of 4, I know that that's going to be 2 root 3. So when I'm multiplying 28 times 2 root 3, which is going to give me 56 root 3. Okay, for 18, what's the perfect square in 18? 9. So the square root of 9 is 3, right? It's 9 times 2. So then what I'm multiplying together here is the negative 12 times 3 root 2. And again, you may have that second, not a problem. What's the perfect square in 24? 4. So the square root of 4 is 2. 4 times 6 is what's 24. So then I'm going to combine those together. And then the square root of 36 is 6, so this is just minus 54. Okay, so now we're looking for like terms. I have the square root of 3, the square root of 2, and the square root of 6. So none of those have the same radicand, so I can't combine them. When that happens, you can just keep them in the order that you FOILed in. Okay, so if you have those two switched, perfectly fine. So if there are no like terms, okay, whatever your FOILed order is, you can keep it that way. Okay? There's no like standard form that you have to adhere to. Okay? I also want you guys to notice that when you multiply these two together, these were complex conjugates. So if you multiply complex conjugates, the result is going to be what? What our answer look like? Well, what was our answer for A? Yeah, just this whole number, right? So anytime you multiply conjugates together, it should equal a whole number. Okay, and that's why on the back page, when we're simplifying, we're going to be multiplying by the conjugate, because if you do that, then you're going to get a whole number instead of a radical. And when you have fractions and you are simplifying them, you do not want a radical in the denominator. Okay, so it just says to simplify. And your questions are going to look like this. 7x over 3 minus root 2. So if you're trying to simplify a fraction, okay, you do not want a square root in the denominator. So we are going to multiply by the complex conjugate. Can you guys think of a time when we talked about what the complex conjugates were? Yes, it does involve an opposite. Yes, yes. So we had to create polynomials and you were given zeros. Good. Okay, so we talked about the complex conjugate theorem when we had to write those polynomials, and they gave you like one of the zeros, something like 1 plus root 5 was a 0, and then you had to infer that if 1 plus 5 was a 0, what else was a 0? 1 minus root 5, okay? When I taught you the theorem, we wrote down a generic example which was if you had a plus b root c, its conjugate is a minus b root c. Now, when we learned that, we really didn't have like the b values. The b value was usually 1, but we are going to see some more complex values today. Okay, so for the complex conjugate that we're multiplying by, we look at the denominator. If it's 3 minus root 2, what is that conjugate? 3 plus root 2. Good. So the only thing that's going to be the opposite is that middle. Okay, and then the first term is going to stay the same. You have to multiply by the same thing in the numerator and denominator, because this means you're multiplying by what value? 1. And if you multiply by 1, you just get the same thing. Okay, now when we do this, I usually multiply the denominator first, because that's really why we're doing this, is so that that will cancel out. So you have 3 times 3, which is 9. And then here, if you multiply by the conjugate, you should get negative 3 root 2 and positive 3 root 2, which is going to make what? 0. Okay, so that's something that you can check mentally. And then if you have root 2 times root 2, if you have opposites, it'll just be minus 2. This should always be a minus if you multiply by the conjugate, because those should always be opposites. Okay, and then 9 minus 2 is 7, so that's going to be our denominator. Okay, on the numerator, we're going to distribute. So if it helps you to put it in parentheses, you can do that. 7x times 3 is 21x. 7x times the square root of 2 is 7x root 2. Okay, and then we are going to take both of these and divide by the denominator, which is 7. Okay, so this was equal to 7, so we're going to split them up to simplify. 21 divided by 7 is going to be 3x. 7 divided by 7 makes 1, so you just have x root 2. And this is going to be your final answer. Okay, cannot combine those terms. Okay, so this is what you're given, root 2 over 4 root 5 minus 4. So we don't want that radical on the bottom. I want you to multiply the numerator and denominator by the conjugate. Okay, so we have 80 minus 16, which is going to give us 64 in the denominator. Okay, on the top when you're multiplying, the outside number is a 1. So this is going to be 4 root 10 plus 4 root 2. So when you have 4 root 10 plus 4 root 2 over 64, we're going to divide them both by 64 and reduce. Okay, you can do whatever's easier for you to do without your calculator. Like if it's easier for you to cut them both in half, like because they're both even, you can. Do you guys know how many times 4 goes into 64? 16, yeah. Okay, so then that's going to leave you with the square root of 10 over 16 plus the square root of 2 over 16. and that's going to be your final answer. Okay, also if you wanted to, 6 times 5 minus 16 is the same thing as 16 times 4, so that's another way you could do that. Okay, so we've done a type where you have a radical on the bottom, and on the top, and for C, this is the last type that you'll have to be able to know how to do. Okay, so you have 2 root 3 plus root 5 over the square root of 3 plus root 5. Okay, so I want you to write what you're going to multiply by. And then we will FOIL and simplify. Okay, which is going to be negative 2 on the bottom. On the top, you're going to have to FOIL. So sometimes putting those in parentheses helps me. 2 root 3 times root 3 is the same thing as 2 times 3, okay, which is 6. On the inside, you'd have the square root of 15. On the outside, you'd have negative 2 root 15. And then root 5 times root 5 is minus 5. Okay, how do we do on that step? Okay, so now what I'm going to do is combine my like terms. I have 6 minus 5, which is 1. I have a negative root 15, or sorry, when I, when I multiplied, you should have a plus here. Because you have root 5 times root 3, so it'll be positive root 15. When you have root 15 minus 2 root 15, this is 1 minus 2, which is going to give you a negative 1. So you can just leave it as negative root 15. Okay, and then this is over negative 2, which we're going to divide both of those by negative 2. So when you divide them, you have 1 over negative 2, which is negative 1/2. Okay, and then a negative divided by a negative is going to switch to a positive. Okay, so that should be your final answer there. All right, and then the rest of the time to work on your homework.